Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. I will be talking about normal and equation of a normal and how to use differentiation to find the normal and the equation of a normal. In the previous video, we found the tangent and the equation of a tangent, but this time we're going to find the normal and the equation of a normal. If you've not subscribed, like, or share, I don't know what you're waiting for, please make sure you do that, all right? So that when I upload new videos, you'll be the first person to know. So you have to click on the notification bell. So I'll get straight to it. So basically, a normal is a line at right angles to the tangent. So if you remember in the previous video, I told you that tangent is a line that just touches a curve, right? This is a tangent. But now, what is a normal? A normal is a line that is at right angle to the tangent. So that means if you have a line here, let's do it this way. So if you have a line here going all the way to this, so this line here is called the tangent, sorry, the normal, all right? While this line that we drew earlier is called the what? The tangent. Okay, so this is the line of the tangent, and this is the line of the normal, all right? So in the previous video, I explained to you how to get the tangent, which we told that the slope of the tangent is called mt, and I also told you as well that the equation of a tangent is y minus y1 is equal to mt x minus x1. All right, so now this time we're going to find but now I want to find equation of a normal this time. All right. So before I go on, let me just write it down just for those that are writing notes. So basically what I said was a normal is a line that is at right angle to the tangent. So if you look at this, this is right angle to the tangent, right? And it's crossing the same point on the curve. So I'm going to write it down so that for those that are writing, we'll have we know what I just said. So a normal is a line at right angles to the tangents. Okay? So a normal is the line that's at right angle to the tangent, crossing the same point. Okay? On the curve. Okay? So for it to be normal, it must be at right angle to the tangent. So the key is its right angle to the tangent, and it's going to cross at the same point to the curve. So that means the normal has to be perpendicular, must have a perpendicular gradient to the gradient function. So that means a normal has a perpendicular gradient, because if the gradient of the tangent, so the gradient of the tangent we've agreed in the previous video is mt. So therefore, the gradient of the normal must be perpendicular. So it's going to be called the mn, all right? So the gradient of this is going to be called mn. So this is going to be the slope of the normal. So this is called slope of the normal, slope or tangent of the normal. While in the previous video, we said this was called the slope or, sorry. So this is the slope of the normal. Okay. This is called the slope of the normal. Change the color. All right. So this slope of the normal. While in the previous video, I told you that this is the slope of the tangent. Okay. So the mt is the slope of the tangent, while the mn is the what? The slope of the normal. All right. So that means the normal must has the perpendicular gradient to the gradient function. So a perpendicular has a perpendicular gradient to the gradient function. Okay. All right. So just a quick reminder, what we talked about in the previous video. So just a reminder, I told you in the previous video that the slope of the tangent is equal to the dy over dx. Okay. And I told you, and I also told you that this is what we call the slope of the tangent. All right. All right. Also in the previous video as well, I also explained to you that the equation of a tangent is equal to y minus y1 is equal to mt x minus x1. And this is called the equation of the tangent. All right. And I showed you and we solved a question on this and I gave you an exercise to try. Now, in this case, if you're looking for the slope of the normal, all right, so now for the normal, it's a little bit different. Now, the slope of the normal is going to be equal to 1 because it's perpendicular, okay? Because it's perpendicular, the slope of the normal is going to be 1, all right? It's going to be the inverse of the tangent, but not just the inverse, it's going to be the negative inverse. Is that okay? So the slope of the normal is equal to what? The negative inverse of the tangent. So don't forget, the slope of the normal is equal to the negative inverse of the slope of the tangent. And so therefore we can also say, so basically the slope of the normal is equal to -1 over the answer you got from the dy over dx. Are you seeing it? And that's how you get the slope of the normal. Now, the equation of the normal is exactly the same thing as the tangent, but instead of having mt, you're going to have mn. So you're going to have y minus y1 is equal to mn x minus x1. And that will give you the equation of a normal. So it's going to be exactly the same thing that we did the last time. It's just that in this case, mn is going to be the equation of the normal. So mt, so remember that we talked about this earlier in the previous slide. So mt here is the equation of is the slope of tangents. Okay. So when you're looking for the equation of the tangent, definitely use the slope of the tangent. But when you're looking for the equation of the normal, you have to use the slope of normal. And the slope of normal is equal to the negative inverse of the what? The slope of the tangent. Okay, good. Now let's solve this. Let's solve some questions now. Now, but before we go into solving questions, let me write down the 6 steps, okay? The 6 steps of finding the slope of the normal and the equation of a tangent. So the first thing you have to do is that you have to substitute x1 into the original equation. Okay, you have to substitute x1 to the original equation to get y1. Now, similar to what I told you in the when we're talking about the slope of the tangent, I told you that in some questions you can be given the x1 and y1. In some questions you might only be given the x1 and you have to find the y1. So at the end of the day, you need to have the coordinates. Hence, you need to find the coordinates x1 and y1. Okay. You need to find the coordinates x1 and y1. And when you're done with that, you then have to then differentiate the y equation using all the previous or using all the previously discussed differentiation mechanism. Okay, so I've talked about several mechanisms in the previous video. I talked about the power rule. I talked about power rule with a constant, how to differentiate lean, everything. So based on the y equation, we now determine what differentiation mechanism to use. Then after you've done that, you then have to then substitute x1, okay, into the y dx, okay? So I remember into the y dx. So because remember, just a quick one, just to remind you, when you differentiate the y equation is going to give you the dy over dx, all right? Or you can call it the mt, okay? So when you differentiate, it's going to give you mt. We've talked about this, which is the slope of the tangent. But now you need to substitute x1 to get the value, okay? To get the value of the mt. So you have to substitute x1 into dy over dx or mt to get the value of mt. So now you've gotten the value of mt, but remember that because we're trying to find the equation of the normal, we don't need mt. What we need is mn, okay? So to find mn, we have to find the negative inverse of mt. So that's where the next step. So we're going to find mn by solving the negative inverse of mt. Okay? So then when you're done with that, you then substitute the value of mn from step 4. Okay? All right? Into the line equation. So you have to substitute the value of mn and the x1, y1 that we got earlier from step 1. Okay? From step 1 into the line equation. I know the line equation that we have is going to be y minus y1 is equal to mn x minus what? x1. All right? So that is it. So let's pick an example, okay? Let me just write the equation for this. So for some of you, so the mn is going to be equal to minus 1 over what? mt, all right? So for some of you that might want to see it pictorially, so you can see it there. So if I find the negative inverse for that, and you differentiate to get that. All right, so when you're done with that, step 6, which is the final step, you then have to then what? Simplify. That's step 6. You now simplify. So after substituting, differentiating, you substitute to get the value for x1, you get the mt, then you find the negative inverse of mt to get the mn. You put it into the line equation to get y minus y1, mn, x minus x1. Then you simplify. All right. So let's pick an example, all right? So let's pick an example to solve this, all right? So assuming we have this question here, right, bring this down a bit. So we're told to now find the equation of the normal of the curve. So find the equation to the normal to the curve having y is equal to 2x cubed plus 3x squared minus 6 at the point of the curve at the point on the curve with x equal to 2, okay? So you can see in this example, they only gave us the x coordinate, but in some examples, you might be given the x and the y coordinate, okay? So let's get started, all right? So let's follow the steps. So step 1, so because we don't have the y coordinate, we need to find that first. So we have to substitute x1 into the original equation to get y1, all right? So that means the y is going to be, we're going to substitute 2 into this equation. So anywhere you see x, you put 2, going to give you 2 cubed plus 3 2 squared minus 6, okay? And this will give you what? 22, okay? So remember, the first thing to do is to substitute. Then after substituting, you then what? Differentiate. So let's go to step 2 now. So step 2, we are meant to what? Differentiate the y equation using previously discussed methods. So if you look at this, we have y is equal to 2x cubed, 3x squared minus 6. So this is a polynomial. You're going to apply the mechanism of differentiating polynomials, and here we're going to apply the power rule, okay? So this is going to give us the y over dx is going to be equal to, if you've not reviewed my previous video on the mechanism of differentiation, please go back and have a look, and so that you'll be conversant, because you can't solve tangents, normals, even stationary points without knowing how to differentiate, okay? So let's differentiate this. So this is going to give us 3 times 2 will give you 6, x, 3 minus 1 will give you 2, plus 2 times 3, 6, x, 2 minus 1 will give you 1. And when you differentiate a constant, is going to give you what? 0. Okay? So that was one of the rules. So we have 6x squared plus 6x squared plus 6x. Now the next thing we're told that we have to substitute x1 into dy dx, or mt, to get the value for mt. So remember, dy over dx is still the same thing as what? Mt. So I told you the y over dx is also the same thing as what? Mt. We talked about this in the previous video, all right? So now we want to get the value for mt. So we're going to substitute x equal to 2 into this. So we know mt, which is the same thing as, this is step 3. Okay? Same thing as dy over dx is going to be equal to 6x squared plus 6x. But to get the value, it's going to be 6. Anywhere I see x, I'm going to substitute it with 2, and that will give me 6, 2. And therefore, the mt is going to be equal to, when you press your calculator for this, it's going to give you 36. Now, but we're not looking for mt, we need mn. So to get the mn, we need to find the negative inverse of mt. So mn is equal to minus 1 over mt. So step 4, we need to get mn, and mn is equal to minus 1 over what? Mt, and that will give you minus 1 over what? 36. So the mn that we're going to use to solve is going to be minus 1 over what? 36. Okay, good. Now that is for step 4. Then step 5, we need to substitute the value of mn and x1 and y1 into the line equation. Okay, so let's go back. So step 5, we need to now get the line equation. So we know that the line equation is y minus y1 is equal to mn. So now this is the equation of a normal, okay? X minus what? x1. So we already know our mn. What's our mn? Our mn is equal to minus 1 over 36. Our x1 is equal to 2. So that means from this stage, our x1 is 2 and our y1 is what? 22. All right. So our x1 is 2, y1 is 22. All right. So we can now put it into the equation now. So it's going to give us y minus y1, 22, is equal to mn minus 1 over 36, x minus what? 2. All right. So let's go on. So it's going to give us y minus 22 is equal to minus 1 over 36, x minus 1 over 36 times minus 2 will give us what? 2 over what? 36. All right. Then we take, if you press your calculator, it's going to give you 1 over 18. It's the same thing if you simplify, all right? But I'm not going to simplify yet. I'm going to simplify later. Then you take minus 22 to the other side because I want to leave it in the slope-intercept form. So if you've not reviewed my video on line equations, I gave you different types of equation of a line. And but in this example, I want to leave it in the slope-intercept form. So it's going to give us y will be equal to minus 1 over 36 x plus 2 over 36 plus, well, we take minus 22 to the other side, and it's going to give you plus 22. Then y will be equal to minus 1 over 36 x, 2 over 36 plus 22. That should give you plus 397 over what? 18. And that is the equation of the what? The normal. Now, if you look at it, the slope of the normal is the negative inverse of the slope of the what? Tangent. And that's how you get it. All right? And that is that for that. So what we can do is you can go to the textbook or the worksheet and try as much as possible to see if you can solve some more questions and see what you get. So what I'm going to do is I'm going to give you an exercise to try, maybe 2 exercises to try and see if you get the same answer. So you can put the answer in the comment section or you can discuss with friends. So let's try this question. Now, this question said they want you to find the equation of a normal. Okay, they want to find the equation of the normal to each of the following. Okay, so each of the curves below are the given points. Okay, so they want you to find the equation of the normal to each of the curves below are the given points. So the first one we have here, we have y is equal to x squared minus 3. And the point they want you to do is as 1 and 3. So you can see in this example, x1 and y1 was given. So that means technically you then have to jump step 1 and go to step 2 to 5. Now, but if you look at the second example I'm about to write, so let's say we have y is equal to 3x squared minus 8x at x is equal to 2. You can see in this example, they only gave you the x1, but they didn't give you the y1. So you need to find the y1 before you start the process. All right. So I want you to go back and have a look and practice and see what you can do and see if you get the answer. You can put the answer in the comment section and try. But if, for instance, you are having problems and still struggling, please feel free to reach out to me. And definitely, I'm going to get back to you. Okay. So that is that for that. So basically, what you need to take home away with is that the equation of the tangent looks exactly the same as the equation of the normal. Okay, but the only difference that in equation of the tangent, you're going to have mt. Okay, so equation of the tangent, you're going to have mt. You're going to have mt. Let me see. Yep. So you're going to have mt. But in equation of a normal, you're going to have what? Mn. So that is the only difference, okay? Then you also need to know that when we talk about Mn, Mn means is the negative inverse of what? Mt, all right? So the negative inverse of Mt, and that is what we call the slope of the normal. We talked about the slope of the tangent in the previous video, so you go back and have a look. And also, when we say the slope of the normal is always tangential, it's always perpendicular to the tangent, and they move the touch at the same points. All right. Okay, so the next video I'm going to talk about the types of function in calculus. I'm going to talk about the increasing, the decreasing functions, and the stationary points. So in order for you to know when I upload these videos, because I'm going to talk about increasing function, decreasing, stationary point, and I'm going to talk about the nature and the nature of stationary point and how to find the nature of the stationary point coordinates. So the next topic is going to be a little bit big because we're going to have loads of things going in there. So that's why it's important for you to subscribe and click the notification button. So when I post the new video, you'll be the first person to know. All right. So see you soon. And I'll see you in the next video where we talk about the types of function. We'll have the increasing function, the decreasing function, and the stationary point. So I'll see you soon.